Continuing the operational experiences theme of this morning's presentation, we're wheeling out another program committee member. This time it's Mike Hughes from Lynx, and Mike's going to be talking about his experiences using passive WDM.
PDF. Go with the PDF.
Get rid of the PDF.
No, go with the PDF. Yeah. I'm guessing it's okay. Keith converted it, so I can. Or somebody else did I? I didn't convert it.
It wasn't.
Wasn't me. It's not linked, unfortunately, so you just need to open it from there.
Sorry.
Okay, that's great. Okay, super. I'm not going to talk to you about line encoding or symbols or DQPSK or any of those things. But what I am going to talk to you about is the experience of not having shelves and not having software to upgrade. And that's basically using passive DWDM to deliver the same or similar sorts of bandwidth that Rob was just talking about, albeit in a much more tighter geographic area. So a long time ago, not so far away, just at the M4, there was an internet exchange, and it had one site for quite a long time, and then that site got full. So it went, oh well, we'll have another site, and it was 4 kilometres away. So it leased some dark fibre. It was, it was 1998, and the telecom boom was happening. So you could go and rent dark fibre. I think we had to buy one of them as being a FIDI circuit and take the terminators off the end of it, but to make it dark fibre. But we leased dark fibre, and we ran 1000 base LX over it, and it worked very well. And that was the Lynx in about 1998. I just had to get the nostalgic diagram out. So over the years, we added a lot more locations and more dark fibre, and then 10 gig was shipped. When 10 gig was shipped, that just worked straight over the dark fibre. But until then, we had to put multiple strands in. If you think back to the early 2000s, when we were just running 1 gig over these strands, we thought, well, if we need parallel 1 gigs, do we buy DWDM gear, or we just buy more fibre? DWDM gear was very expensive. It was actually quite new at the time. And we really just thought, let's just go and get more fibre. So that's what we did. 10 gig shipped, it just worked, same G652 fibre that we've had all the time. Just put it on there, and on it came. Of course, all the distances were still less than 10 kilometres, so it was kind of easy. As the traffic grew, we then trunked up 10 gig, as the switch at either end of the link could support trunking of 10 gigs. This wasn't there on day one, but as it did, we then just trunked 10 gig over multiple fibres. So why are we now looking at passive DWDM? Well, what we started to see was that the London fibre glut from the early 2000s, that was all being consumed. People had overbuilt, people had gone bust, there was distressed assets. The sales models were based on just renting out the assets and maybe not even trying to actually recover the cost of actually having the things there in the first place. So what we saw was pricing was going up. The other thing that happened was that business rates became payable on strands of lit fibre. So taking more and more strands of fibre in the street wasn't a sensible plan. You also had a lot of buildings were bringing in monthly recurring charges for the in-building cross-connects. Now, if you think back to a long time ago, these things used to be free. You'd put them in yourself, or you'd have somebody put them in for you. But then along came the idea of the Meet Me room to try and get around those horrible cable cram risers and rat's nests of fibre that were basically growing in any colo that had been around for any length of time. So you were paying a monthly recurring charge for every pair of fibre that you had there. All those things worked in DWDM's favour, along with technology changes. Fixed optics, if you think back to the original 10 gig cards that we were buying, certainly in 2002, they were fixed config. They had this big blue brick of an optic mounted straight on the board, 300 pin MSA optics. Some of you might remember those. And then the fibers were just presented on the front to plug into the network. Then along came pluggables, initially Zenpak and then XFP. Made it was easy to change the optic type, and that was both in the in IP Ethernet gear we're using and in DWDM kit. So actually in active DWDM terminals, they all started to use pluggables as opposed to fixed transponders. That, of course, increased the availability of DWDM pluggables as a commodity, reduced the price of them. The other thing that we saw in the kit was support for very wide lag bundles in the network gear, and I'm talking 4 and 8 times 10 and maybe even beyond, which is what we're looking at now. So that meant rather than considering going to 40 gig as a physical interface, it was more effective just to take more of the same and trunk it together. So passive DWDM, what am I talking about? I'm talking about the MUX-D-MUX element. It's just an unpowered OADM. There's no shelf that takes power, that has software, that has management software, that needs a management connection. It's a box with some optical ADMs in, and if you're into physics, there's some Bragg gratings and all those kind of things going on inside. It's transponder free. There's no conversion from grey light to a DWDM color, to an ITU grid color. Instead, what we're doing is we're taking the same optic and we're putting that actually into the network kit, so we're just plugging it straight into the Ethernet switch. It's saving on the cost of the additional powered equipment, and it's saving on, if you think about it, two sets of 10 gig optics, one at each end of the span as well. What did our deployments look like? Well, initially it was what I call poor man's WDM, 1310 and 1550, readily available optics, just a two-way split. And that was done to solve a specific problem. We just put that in, and that was our first sort of toe in the water. That was actually then taken out when we put 10 gig in, and we moved to ITU grid DWDM, initially with 8-channel MUXs and 40 kilometer DWDM XFPs. Very small number of spans, just a couple initially. But what we tended to find is that as time passes, the traffic's going up, the amount of stuff we're trying to put down one fiber is increasing. So 16-channel MUX is then becoming the norm. And we're also putting in longer reach optics because, as some of you know, we've gone out and opened 3 new locations, and one of those, the fiber distance, is nearly 80 kilometers away. So here's the current platform. I don't know whether I've got a pointer here. I don't think I have. I can use that. This is the current example of the platform. So all the very wide links that you see here, these are all DWDM now. Certainly here, and those are all sort of short reach. They're all 40 kilometer. What we've got out here is we've got 80 kilometer here, and these are also DWDM. There's either 2 or 4 wavelengths running down the same fiber. Capacity to go up to 16 and beyond. And again, these are another pair of very long segments. So these are all in the region of 30 to 70 kilometers. Everything on this side of the screen on the right is all in Docklands. And that, when it's within the same building, is obviously just using native grey light at 1310. If there's only a single 10 gig channel, that's 1310 again. But when you've got multiple circuits going between sites, that's now being lit at DWDM, just regular ITU C-band. Where are we now? So we've got 12 spans currently deployed, and that equates to about 100 DWDM XFPs that are deployed in the equipment today. We've actually got more to do now. We've got probably about another 60 or so XFPs sat in the office, so probably about another 32 lambdas to deploy, and about another 8 spans that need doing. We're usually 8 by 10 gig on a single fiber. That's certainly the biggest we're running. We're about to go up to 12, and then eventually 16. We can scale up to 32 lambdas on a fiber easily. If we're putting the 16-channel MUX in, we can have an express port that spits out the next 16 channels, and we can stack MUXs. the insertion loss of that kind of split's not too significant. The good thing for us, generally speaking, is it's just worked. We plugged it in and it's worked, and that's why we've been really happy with this, and we're going down this route. As long as you're doing your setup carefully and you're cleaning everything up before you plug it in, everything just works. And as long as the fiber's handed over in good condition, or even if it's old fiber, as long as you get the OTDR, you shoot it and you make sure there are no bad patches, dirty patches, poor splices, or any unusual artifacts, then you can be pretty certain that it will just work. The longest span in the existing deployed network is 68 kilometres as handed over from the carrier plus the local tails. That's currently got 4 lambdas on it. That's running fine. That's going to go up to 8 by 10 very, very shortly once the optics come in. I'll come on to a story about that in a minute. And it all just works really, really well. So what equipment are we using at the moment? We're using the Cube Optics passive OADMs. They're made in the EU, they're made in Germany. They make a range of different types. And then we're just using 10 gig XFPs, and they're going straight into the switches, both in 40 kilometre and 80 kilometre reaches. We're not buying them from the vendors, so if there's any vendors in the room, I'm afraid your markups scare us off. They're mostly either direct from Finisar or from Luminant or from their European importers. Price-wise, they come out at roughly 10 to 15% of the price that a qualified optic would go for. Passive muxes, depending on the number of wavelengths, they're somewhere between 1,500 to 2,000 per unit, so £3,000 to £4,000 per span. And then the optics, roughly 1,200 for a 40 kilometre one, and obviously the 80 kilometre reach, slightly more expensive. And as I said, you're looking at 10 times that price sometimes for one that's got a vendor sticker on it. So what are the gotchas if you're going to try and do this yourself? One of them is optic locking. See my presentation from UK North 9. I can't say it enough. Vendor qualified optics, you are paying a lot of money for that sticker. The OAM may not work. I don't know if I said OEM. OAM may not work at all, or the digital diagnostics won't work in some vendors. This is nothing to do with the optic manufacturer. This is to do with the person that makes your piece of network equipment. They have decided somewhere in product management that they want to protect their margins, and to try and make you do that, they'll just cripple things despite these things actually being defined in a standard. Or what you might find is the worst you'll get is nag messages in the logs, unsupported optic in slot X/Y, and you may get 1 or 2 of those a day. You just train your network monitoring system to ignore them, of course. The other gotcha is fibre cleanliness. I said it has to be clean. The OTDR trace I've got on the right, that was from this very long circuit, 68 kilometre circuit that was handed over. The loss on that circuit was pretty much textbook in terms of loss per kilometre and loss per splice. It's mostly spliced all the way through, not that many patches. DWDM is sensitive to things like dirt. Invest in proper tools like Cleatop so you keep your fibre ends clean. And if you can afford to get cable fibre testers like OTDRs and things like that, they'll save you a lot of trouble in terms of when you come along and do your debugging later. And that's probably the main difference from just running vanilla grey light, either 1310 or 1550 10 gig, where you just put it on the fibre and it tends to work. What else can I think about? This one is logistics. I know one of the things that Rob said was getting DWDM equipment was a logistical nightmare sometimes. For example, getting those spares when that thing was broken took 2 weeks. Think yourself lucky. Sometimes we've ordered in optics and they've taken 3 months to 4 months to come in. These things appear to be made in very, very small batches, often almost to order, or until they need to get like a specific yield before they can go ahead and make a batch of channel 29 or whatever it is. XFP is fairly common, so you get reasonably good lead times on that, particularly if you're ordering in a big enough volume. But exotic types such as X2, you can be looking at quite a long time to get fibre, so you get the optics in. So sometimes the advantages of having spare slots in your MUX, and you think, well, I can quickly go and turn up another wave there, If you've not got the transponders actually in stock, you could actually be waiting several months for those to come in, and you could actually be better off just ordering another fibre because the carrier might turn that around quicker. The other thing I can think of is you've obviously got SFP Plus now growing in popularity, so this is 10 gig in an SFP form factor. The MSA specifies a lower power per interface, and at the moment that can't drive 40 kilometre, 80 kilometre optics, that, and therefore the wavelength range that you get in the C-band for DWDM. Where else could you get your kit from? There's a list of various suppliers there. GHIP seems quite common. You could buy direct from your system vendor, but what you find is the vendor badge pluggables, they're usually sourced from a standard OEM. They're often Finisar. If you go and buy from your vendor, you get it, you plug it in, you look at the serial number, it's obviously a Finisar serial number. You could go direct to the transceiver companies, or well, actually direct to their EU importers. The problem that you've got is whether they will sell to you in a fairly small volume. I mean, we've been ordering at least in the high tens, if not occasionally 100, and they'll sell to you in that sort of volume. So I think in all, sort of summing up, is, you know, it cuts out a piece of active equipment that, you know, you've got one less vendor to worry about. You've got support contract not to worry about. You've not got to house a chassis and power it and have transponders in stock. It should just work with your existing network gear as long as it's got, you know, a standards-based pluggable interface in it. With a bit of planning, you can make it easily expandable. You know, always maybe keep a spare wavelength in stock. And indeed, it should save you some money in the long run because, you know, DWDM gear isn't the cheapest, you know, active gear. You may need to spend a bit of money on fibre hygiene kit if you don't have it already. That's it. Questions? Curtis.
Yeah, hi, I'm Curtis Linkers from NetNode. So I have maybe a strange operational question, but in this case, you control both ends of the fiber, so to speak, right? And you control all the equipment, and therefore passive VDM systems might be easier to deploy because you control the XFPs and the coloring. Mm-hmm. Do you have any view of how hard it would be for you to deploy this to a customer-facing scenario where you actually would force the customers to have this and without any monitoring of the links? I
have deployed it to a customer. There's one of them in the room.
Okay.
So his router is remote from the link switch, and there's a piece of dark fibre in sight, and there's 8-channel MUX, and there's 3 colours lit on it. We just picked the colours. They ordered their side. We ordered our side. The colours are standard.
Right, but you don't think that doing this on a larger scale would be an issue because you have no monitoring, no insight into the systems?
It generally just works from what we've seen. I mean, you know, if having both ends, you can obviously see the link state at both ends. You can see the receive power at both ends.
Right.
From what we've seen, as long as you take care when you set this stuff up and you check this stuff out when you set it up, unless there is actually some sort of bad fibre event, either like a fibre break and then the repair is done badly, you tend not to have to go round that cycle again. If you provision properly in the first place, it just seems to work forever.
So you don't think there's any value in a more advanced, in an active system for this?
Not in this situation, no.
Right.
I mean, we have actually got some active DWDM kit ourselves, but we use that for something else, not for linking the main core switches.
All right, thank you.
Yeah, there's a question there again.
Ben Roder, SohoNet. What do you use the active DWDM equipment for then?
Basically hauling private interconnect between sites. It's actually relatively new. We've only just got it. It's just being put in at the moment. And that's basically for doing offload from the main platform. If you imagine Rob's graph that had 15 gigasecond on a 40 gig link, I mean, we're probably doing something in the region of 60 to 70 gigasecond on an 80 gig link, and we need to upgrade it, and we are upgrading it. But the issue we've got is 100 gig is not going to ship at least until the middle of next year, and the density of switches, we're just generally concerned about that anyway. So one of the things that you need to do is you need to identify very large bulk flows. and offload them. Now, when they're in the same site, that's dead easy. We can just go to the members involved and go, here's some fibre, plug each other together, and don't run this over the switch fabric. When they're not, excuse me, when they're not in the same site, then we need some way to facilitate that. What we have been doing is the number's been relatively small, and what we've done is we just sourced them some dark fibre, or indeed let them have some dark fibre that's come spare because we put WDM on the main platform. What's happening is that's increasing, so we need to be able to offer to do that in a more scalable manner. And we looked at doing that using passive, but not everybody is comfortable doing that. I think the member that we did passive DWDM to the Switch platform, they were comfortable doing it. We discussed how we're going to do it, and they were happy doing that. But not everybody's going to be happy doing that. So you need to be able to offer something that takes grey light in and turns it into something else. Effectively, we're doing that with the Switch platform. We're just hanging them off a 1310 interface. So that's the reason that we go with an active platform there. But where we're doing such a big bulk blob of traffic just between these two locations, and you don't need any recovery, or because that's managed at a higher layer, that's managed at layer 2, then you just don't need that, and you may as well just do it using passive equipment and save yourself some time and effort and money. And I think I'm good for time, yeah?
Any other questions for Mike?
Okay, thanks very much.
Okay.
It's really cool. I advise it. It just works.
Okay, thank you, Mike.